wabarakatuh, and hi everyone. For this video, I'm going to discuss the topic 4, which is matrices. For the first subtopic, which is the introduction for matrices, at the end of the lesson, the student should be able to, the first one, identify the different types of matrices. Next, the student should be able to perform operations on matrices. And lastly, the student should be able to find the transpose of matrix. So what is basically does it mean by matrix? So a matrix of an order m by n is a rectangular array consisting of entries of elements in m rows horizontally and n column as vertically as shown below. A matrix is called m by n if it has m rows and n columns, and the matrix for which the entry is in rows I and in column J is denoted by Aij. Let's say if you are given the rectangular array consisting of entries as this one. So how are we going to identify the numbers of rows and the number of columns? So the number of row is taken by horizontally, which is, we call it as the first row, this is the second row, this is the third row, and so on. So how about the column? So the number of column we identify as a vertically. So basically this is the first column. So this is the first column. This is the first column, and this is the second column, the third column, and so on. By identifying the number of rows and columns, you can identify the order of the given matrix. So basically the order of the given matrix, we rewrite it as a matrix A, m by n, which is m is stand for the number of rows and n is the number of columns. Okay, let's go to the example 1. State the order of the following matrices. So we go for the A. You are given the matrix A, which is the entries is 2, 1, 1, 3, 4, 5. So how are we going to identify the order of the matrix? So the order of matrix stand by m by n. So what is m? M is a number of rows and n is a number of columns. So we are going to identify how many columns that form this matrix. Okay, so basically this is a number of rows. This is the first row, second, and third row. So basically we have 3 rows. So this is 3 rows. So A by 3, A of 3 by the number of columns. So the number of column identified by vertical as a in vertically. So as a vertical form, it should be 2, 1, 4, 1, 3, 5. So it means that the order for the first matrix is A, matrix A 3 by 2. Okay, for the example 1C, you are given the matrix 1, 2. So 1, 2 means that you have only one row. So this is the only one row. You have only one row, and you have 2 columns. So it means that the matrix of C of 1 by 2 matrix. So now we are going to proceed with the example 2. You are given the matrix A with its entries. So the first question asks for the order of A. So order of A, what you need to do is you have to identify how many rows and how many columns do we have for here. So we have the first row, second row, the first column, second and third column. So basically the order for the matrix A is 2 by 3. It must start with the numbers of row first and continue with by the number of columns. So next question, if A is given by A of ij. So I stand for the numbers of row. So A stand for the number of row, J I for the number of rows, J for the numbers of columns. Identify for A21 and A21 and A13. So how we are going to identify the entries of or the elements of A21 and A13? So what you need to do is you have to compare with the general forms of the entries of a matrix. Okay, so since the given matrix is by 2 by 3, so it means that the first entry, since this is the location of, this is the first row, second row, first column, third column, and first, second, and third column. So the first entry given here is A4 1 1. So why we write it as A11? So A11 means that the locations of these entries, the location of these entries is by the first row and the first column. The first row and the first column. Okay, what's next? What is the entry for the next part? Okay, next part, if we write these elements or these entries, this location is for the A12. So what does it mean by A12? A12 means that the first row and the second column, the location of that element or that entries is to be at the first row and the second column. and follow with the next entry. So the next entry should be A13. Right? So down here, the element here or the entries here, it should be A21. Okay. So now we turn to the row number 2, the second row. So that's why we write it as A21. So it means that it's the location of the entry is for the second row and the first column. And you just write down the next one. So this one should be A22 and this one is by A23. So since the question asks for the A21. So A21 means that the elements or the entry for the second row and the first column. Second row and the first column. So the second row and the first column should be right here. Okay, right here. So what is the element for A21? So A21 it should be -2. So the answer for this one is -2. Then next, the question asks for the A13. A13 means that the first row and the third column. So the first row and the third column. First row with the third column with which element? Okay, which is a -9. It's a -9 as the answer. And then we proceed for the next question. Find the value for A11 plus A22 plus A23. So A11 plus A22 plus A23. Okay, you just need to identify the correct elements or entries. So A11 is 5. A22 is 3. A23 is -7. So you just need to calculate and you will get 1 as the final answer. Okay, now we proceed to the equality of matrices. The equality of matrices, the 2m by n matrices are equal if they have the same dimension and their corresponding entries are equal, which is we can say that generally it's totally with the same thing. So we can say that these two matrices are equal. So for example 4, which matrices below are equal? So you just need to observe and identify and just give it the answer. So from here we have matrix A1, we have matrix A1, 2, 2, 1, matrix B1, 2. Obviously A and B are not equal. And then we have matrix C, 2, 1, nothing equal to this until now we can't identify any matrices that equal. And then we go for D. We have 1 2 2 1. So now we can spot one of the equality, one pair of equal matrix. So we can check for another matrices. We have a 2 1 2 1. Okay, nothing equal for this matrix, and also for F. Okay, so we just only identify one pair of equal matrix, which is A equals to T. So that's it. Okay, for the example 5, you are given the matrix A and the matrix B with the same n dimensions. Find the values of A, B, and C, values of A, B, C, and D such that A equals to B. So this is the equal matrix. So how are you going to find all of these values? So what you need to do is just compare these two matrix, just equate these two matrix. So I'm going to write down this matrix A, which is 3 minus A, 6, 4, 8, 4, B, 2, equal to 9, 6 minus C, 4, 2 minus 3D, negative A, and 2. So how to find the A, B, C, and D? So since these two matrices are equal, so you just need to compare according to its entries or elements. Okay, so means that the 3 minus A is equals to 9. So you just need to take out these two things and equate, and then you just solve it to get the answer. So the first comparison, so we compare. So the first comparison that we get is 3 minus A equals to 9, which is, it will give you A equals to negative 6. And then next comparison, okay, just compare whatever can be compared. So we have the next comparison, we have 6 equals to 6 minus C. So that will give you C equals to 0. So now we have two unknown here. We have two values of the unknown that we have to find out. And next we can compare. So 4 cannot be compared with 4. Okay, next comparison might be this one, 4B with 8 with 2 minus D. So just need to compare this. 8 equals to 2 minus 3D. So we just calculate. So negative 3D equals to 6. So D is equals to negative 2. And the last comparison, just compare 4B equals to negative 8. So B equals to negative 2. So we have settled. We have done for this question. Right, the next part, we are going to go through with a few types of matrices. So the first type of matrices, we call it as a row matrix. So row matrix means that the given matrix is only consists of one row. So this is the example for the row matrix. Next, we have column matrix. So column matrix means that the matrices given only have one column. So this is the example. And then we have the square matrix. So the square matrix means that we have the same dimensions. For example, 2 by 2, same dimension with its row and its column. So maybe you can have a 2 by 2, 3 by 3, 4 by 4, and so on. And then we have a zero or null matrix. So zero or null matrix means that all the entries given are 0. Okay, basically all the elements are 0. And we have diagonal matrix. Diagonal matrix is usually for a square matrix. Okay, and which entries outside the main diagonal are all 0. So what is mean by diagonal matrix? What do you mean by diagonal entries? So this is the diagonal entries. This is what is mean by what does mean by diagonal entries. Okay, so all the elements outside the main diagonal entries are 0. So that's what we call as a diagonal matrix. And then we have identity matrix. So identity matrix is for the especially for the square matrix with with the diagonal entry, the diagonal entry is with the element consists of the elements 1. Okay, it's basically identity matrix is a subset to the diagonal matrix. Okay, to be more specific, the diagonal entries is consists of entries 1. Okay, entries 1. Okay, and then we have lower triangular matrix. So lower triangular matrix, it means that all the entries above the main diagonal are 0. So basically this is a triangular that we can form. Above this triangular are consists of 0 entries. That's what we call as a lower triangular matrix. And then the opposite for the lower triangular matrix is the upper triangular matrix is matrix with all the entries below the main diagonal are 0. So the triangular here is like this. So it's upper than these entries. These entries are 0. Now let's proceed to another part. Basically, there are 4 types of operation that involve a matrix. The first one is additions. So in order to perform the addition between matrices, it must be compatible in terms of its dimension or its order. So we go for the example 1, example A. So the first matrix here given is by the order of 2 by 2, and the next one is also by 2 by 2. So since these both matrices are equal or same with its dimension or its order, so we can perform the addition between these two matrices. So how to do the addition? So you just need to add according to its entries. So means that the first entry, which is for A11, it must be add to the next matrix with the same entry. So 1 should be add with 4, which is both are with the same entries for its matrix. So 1 plus with 4 will give you 5. And do the same process for the other entries. So let's say we have here is 2. 2 should be plus with 3. So 2 plus with 3 will give you 5. And you just follow the same process for the next entries. So means that the next entries here should be negative 2, since it is a product of 3 minus 5. And the last one should be 10 because of 4 plus with 6. Okay, so for the next example, which is B, for the first matrix given here is by the order of 2 by 2. And the second matrix here, it should be add with this matrix with the order of 2 by 1. So obviously, we can see here, these both matrices are not the same in terms of its dimension. So they are not compatible to perform the additions. So you cannot get the answer for this question. So you can just conclude here, A and B are incompatible. Okay, so now let's move to another operation, which is subtraction. Subtraction is almost the same with addition. So it's only the only difference is just whether you need to add or subtract. So it means that this one, it must be in order for you to do the subtraction between matrices, it must be compatible to the same with additions, compatible in terms of its dimension or its order. So we go for the first example. The first one is by the order 2 by 2, and also for the second one. So since they're having the same dimension, so you can just proceed with the calculation of the subtraction between these two matrices. So what you need to do is just minus according to its entries. So means that 2 should be minus with 1, and just follow through the same process. So the answer that you will get here is the first entry should be 3. Sorry. Okay, 2 minus 1, you should get 1. And just follow the same process. So 3 minus 2, you get 1 and 1 here. And the last entry should be 3. Right, so we proceed to the next operations, which is scalar multiplication. So this is the scalar multiplications. So what does it mean by scalar multiplication? So the situation is when you are given a constant or a scalar. This is a scalar or a constant, you can call it as a constant, multiply to a certain matrix. It doesn't necessarily to be involving more than one matrix. So for this case, what you need to do is you just need to multiply the constant here outside here to the each entries or each element of the given matrices. So you can just calculate. So negative half multiply with 2, so you get 1. Negative half multiply with negative 4, you get 2. Negative half multiply with 8, so we get negative 4, and so on. So this one you get negative 5/2, 3, and the last one negative 7/2. So that's the final answer. And we are going to continue with the last operations. Okay, the fourth operation that involving matrices. So multiplication of two matrices. Okay, basically, okay, you have to remember that if you are given the question with the matrix A multiply with matrix B, so basically A multiply with B is not equals to BA. So means that if you change the order of the multiplications, it doesn't give you the same product. So if the question asks you for A multiply with B, so you just need to follow the order. You cannot change the order. So AB is not equals to BA. And also, if you want to perform the multiplication of two matrices, it has to be compatible. So the compatibility must be follow this condition. So let's say we want to multiply with matrix A with its dimension m by n, multiply with matrix B with its own dimension, so m times m by n. So how to check the compatibility of the multiplication of two matrices? So you have to look at this value, at this number. For the first matrix, we just focus on the number of columns. So the number of column here is denoted by n. And the second matrix, you have to look at the numbers of row. So these two numbers must be the same value. Means that the column for the first matrix should be the same value with the row for the second matrix. So we can say that if both are the same value or the same number, so you can say that it is compatible to perform its multiplications. So and then for the extra note here, the product of the multiplications of these two matrices, the product after you do the multiplication of these two matrices, the order of the product is by this value. Okay, this is the order of product of A times B. Okay, so now let's do the example A. So for the example A, the first matrix stated here is the order for the first matrix is 3 by It's 2 by 3. It has 2 rows, 3 columns. And the second matrix here is, the order for the second matrix is by 3 by 2. So let's check the compatibility. So these two values must be the same numbers. So since this is since this satisfied the condition for the compatibility, so you can just proceed. Can proceed to do the multiplication of these matrices, which is the product of the multiplication is the order of the product of the multiplication is 2 by 2 matrix. So how are we going to do the process of multiplication? So the process of multiplications, it must be in between of row multiply with column. It must be row, column, row, column. So means that we are going to start with the first row, row multiply with column. So we're going to start with the first row and with the first column. Alright, so the first process is you have to multiply. You have to multiply each of these entries. So it means that 1 need to be multiplied with 2. So 1, okay, you can just write down here in a big bracket. So 1 multiplied with 2. And for the next pair of multiplication, which is 2 multiplied with -3, before that you have to put the sign of add. So you have to add every single pairs of multiplication of this value. So 1 multiplied with 2 plus with 2 multiplied with -3. And lastly, plus with 3 multiplied with 2. So this product will give you the first entry. So just proceed for the next part, the next entries, which is just maintain the first row and you multiply with the second column. Okay, just maintain the first row for the first matrix, but need to change for the second column. So just do the same process, just repeat the same process. Okay, just repeat the same process. So 1 will be multiplied with 1. So 1 multiplied with 1 and plus 2 multiplied with 4. And lastly, 3 multiplied with 1. Right? Okay, next, we're going to change the row for the first matrix, which is the second row. Need to be do the operation for the first column. So just proceed, just repeat the same process. So -2 multiplied with 2 plus 0 multiplied with -3 plus 5 multiplied with 2. And lastly, you're going to do the second row with the second column. So -2 multiplied with 1 plus 0 multiplied with 4 plus 5 multiplied with 1. So you just need to calculate all of this value to get the final answer. So the final answer for this question is 2, 12, 6, 3. So we're done for the first example. Now we are going to discuss the example C. You are given a matrix with dimension 2 by 2 and the question asks to find the A squared. So what does it mean by A squared? So A squared is A multiplied with A. So just need to write down this matrix 1, 2, 3, 4 and do the same things once again 1, 2, 3, 4. So you have to multiply these two matrices. Just need to do the same process from what we have discussed from the previous part. Okay, so focus on the first row, the first column. So 1 multiplied with 1 plus 2 multiplied with 3. And next columns. So 1 multiplied with 2 plus 2 multiplied with 4 and we're going to change the row, second row with the first column. So it means that 3 multiplied 1, 4 multiplied with 3, and lastly second row, second column. So 3 multiplied with 2 plus 4 times with 4, and you just need to calculate. So that will give you 7, 10, 15, 22. Okay, we're done for the C, and the last example that we could discuss is for the example F. Find a matrix B such that, matrix B is multiplied with a matrix, equals to another matrix. So how we are going to find the matrix B? Since the question doesn't give you any clues of what is a matrix B, what is dimension, what is the order for the matrix B, no clues at all for the matrix B. So we back to the what we call it as a compatibility of multiplications between two matrices. So we should know that if we have matrix A of m by n, B of m by n, it will produce you C m by n, which is it must be compatible in terms of this value. This value must be the same, n and m. So since the product, since here here is 2 by 2, this one also 2 by 2. So in order to produce a matrix from the multiplication of two matrices, it must be compatible. So if these two are compatible, so means that this value must be the same with the column for the dimension of matrix B. So it must have the value of 2 here, right? So it must be 2 and 2. So what's the number of rows for the column for the matrix B? So the number of row you can get it from the dimension of the product itself. So the product itself is come from this value. This is the order of the product. Right. So since this value is 2 by 2, means that this should be 2. This is 2 by 2. It must be the same. Right. So means that we get one clue, which is the matrix B is the dimension for the matrix B is by 2 by 2. So let's say we denote that the matrix B as a value consists of elements x, y, z, and e. Or you can just write any notation that you prefer. It might be A, B, C, D. You just need to denote the notations. Okay, let's say the matrix B consists of the entries x, y, z, and e. So we are going to replace this matrix right here. So you get x, y, z, and e. Multiply with 0, 1, 2, negative 1 equals to 2, 1, negative 1, 0. Right? So for the left hand side, you have to do the process of multiplication of two matrices, which is it must be involving row and column. It must always be row and column. So just do the same process. X multiplied with 0 plus y multiplied with 2, and proceed with the next column. So x multiplied with 1 plus y multiplied with negative 1, and lastly z, next z multiplied with 0 plus a multiplied with 2, and lastly z multiplied with 1 plus a multiplied with -1. And for the right side, just follow through. Right, so when you have done the listing all of these operations, so you have to simplify it first before you compare. You have to simplify in the simplest form. Alright, so here you will get 2y, x minus y, 2a, z minus a equals to 2, 1, -1, 0. So how to get the value of x, y, and z? So you need to do the comparison. So you have to compare according to its entry. So 2y will compare to 2. 2y equals to 2. So that will give you y equals to 1. And maybe we can proceed with the next entry. X minus y equals to 1. So since y we have 1, so x minus 1 equals to 1. X will give you 2, and 2a equals to -1. So a will give you -half, and lastly z minus a. Lastly z minus a equals to 0. So z equals to half. Z equals to -half. Okay, sorry. Z equals to -half. So we're done. Okay, let's move on to another parts. Okay, here we have algebraic properties of matrix operations. So I guess you can go through by your own. So I'm going to discuss the transpose of a matrix. Okay, now we proceed to transpose of a matrix. So the transpose of a matrix, okay, written as A of T, is a matrix obtained by interchange row and columns of A. That is, the ith column of A is the ith row of A. Okay, so we go for an example. Let's say if you are given the matrix A, which consists of the entries 3, 2, 0, 2, 1, 3, 5, -5, 7. So we want to find the transpose of the matrix A. So what you need to do is, from the row 3 to 0, you have to interchange become the column. So this 3 to 0, originally it's forming a row for the matrix A. So once you transpose, it will become a column. So the first row will interchange become the first column for the transpose matrix. So the same thing goes for another row. Let's say for the second row here, we have 2, 1, 3. So when you want to transpose, this row will become the column. So it's originally the second row, so it will become the second column. And we can see here the last row, which is 5, -5, 7, it will form the last column for the transpose matrix. So for the matrix B, we can apply the same thing. So if you want to interchange, you can interchange row becomes column or column becomes row. It's the same things. So let's say for the matrix B, if you want to change which is it's originally as a column, so you want to find out the transpose. So from column it will change become row. So the first column will interchange become the first row to find out its transpose. Okay, so you can do the same thing for the next column. So this is the second column, it will become the second row. Alright, so that's it for the how we are going to get the transpose of a matrix. So we go for the properties. Here we have 4 properties listed. So the first one, we can see that if A plus with matrix B, so we have 2 matrix, matrix A plus with matrix B, and then afterward you transpose the product of the output of this matrix, it's actually equivalent to A transpose. plus with B transpose means that you transpose it first. You transpose it first separately, and then later on you add these two. So it's just the same process. If you minus these two things, A minus with matrix B, and you transpose afterwards, is equals to A transpose minus with B transpose. So next properties here, if we have A transpose and you transpose it once again, you will get back the original matrix of A. So next properties, if you multiply matrix A with matrix B, and then later on you transpose this product, it's equivalent to matrix B transpose multiply with A transpose. And lastly, we have this constant, which is K constant, multiply with a matrix A, and then later on you transpose. Is equals to, you transpose the matrix A first, and later on you multiply with K. It will give you the same matrix, the same answer. So you are given 4 matrices. You are given the matrix A, B, C, and D. So let's go for the A transpose. So how are you going to do the A transpose? Alright, so we can see here for the matrix A, you are given the column matrix, the row matrix, because it only has one row. So means that if you want to find the transpose, so you have to remember that you need to interchange row become column or column become row. So since this matrix has one row, so if you interchange, if you find the transpose matrix, so row interchange to column. So basically it started with the row, so you change become columns. So now we're done for the transpose. It's just easy process. You just need to interchange row become columns. So next question, find the B transpose, the transpose of the matrix of B. So the matrix of B, this is we call as a column matrix because it only has one column. So you just need to interchange this column become row. So originally it's a 2, 1, 3 by vertically, so you change in horizontally, so it becomes 2, 1, 3. Okay, next we proceed with C transpose. Okay, for this matrix you are given 2 by 2 matrix, so just focus on row or column, either one of this. So let's say we focus on the first row. So the first row is a 2, 2. So we are going to change become column. So 2, 2. And the second row here is 3, 4. You have to change become the second column. So it will be 3, 4. And just do the same process for T in order to find the 3 transpose. Focus on the row, interchange become column. So you get 1, 3, 3. And proceed the same process. So 2, 5, 4, 1, 3, 5. So we're done for the process of transpose for each of the given matrices. Okay, so we have another 2 question here, which is AC transpose. So how you are going to get the AC transpose? Okay, so back to the properties here. If you want to find out the AC transpose, you can apply these properties, or you can just directly find out according to the question itself. So either you multiply it first before you transpose, or you transpose each of this matrix and then you multiply it afterwards. So It's just the same. So let's say I would like to multiply these two matrices first. So matrix A, since the given matrix A is a 2, 1, 2, and the matrix C is 2, 2, 3, 4. Okay, multiply it first. So multiply these two matrices, you will get 8, 10. And find out the AC transpose. So AC transpose means that 8, 10 become columns. Right, return. And last part of this question is DB transpose. So multiply it first. So maybe we get multiply it first, DB. So the matrix D is 1, 3, 3, 2, 5, 4, 1, 3, 5. Multiply with matrix B, which is 2, 1, 3. So multiply these two matrices. You will get 14, 21, 20. So since the question asks for the DB transpose, you just transpose this, column become row. So 14, 21, 20. Right, so we're done. Okay, let's move to the last part of the first subtopic, which is the symmetry and the skew symmetric matrices. So what does it mean by the symmetry matrix? Okay, basically it's a square matrix that is satisfy this condition, which is the transpose of a matrix is equals to its original matrix. So this is the example for the symmetric matrix. So next we have the skew symmetric matrix. So the skew symmetric matrix, it will satisfy this condition. The matrix A is equals to negative A transpose. So let's proceed to the last example. So the last example, you are given the matrix A and the matrix B, and the condition, which is 2A minus B, is a symmetric matrix, and you need to find out the value of P, Q, and R. So what does it mean by symmetric matrix? So symmetric matrix, it must follow these conditions. A equals to A transpose. Okay, so since the question states that 2A minus P is a 3 by 3 symmetric matrix, so you have to follow the condition that 2A minus B equals to 2A minus B transpose. So find out the 2A minus B first. So 2A minus B means that 2 multiplied with matrix A, which is 3, 5B, Q, 1, 1, 5R2, minus with matrix B, 2, 9, negative 4, negative 3, 4, 0, 10B, 1. Alright, so simplify it first. So 2 multiplied with 3 minus with 2. So you get 6 minus 2, which is 4. Okay, just proceed the same process. 2 multiplied with 5 minus with 9. So that one will give you 1. And follow through. So I just give you the simplified form, 2p plus 4. And this is the 2q plus 3, negative 2, 2, 0, 2r minus b, and lastly 3. So this is basically the 2a minus b. So in order to find out the value of p, q, and r, so you have to compare these two parts. Okay, equate these two parts. So since 2a minus b is equals to 2a minus b transpose, okay, so for the left side, you just copy down whatever you have done the simplified form. So just copy down here, 4, 1, 2p plus 4, 2q plus 3, 0, negative 2, 2, 2r minus b, 3, equate to the transpose of this matrix. So the transpose of this matrix means that 4, 1, 2p plus 4, you change become columns. So 4, 1, 2p plus 4. This is the second row, becomes second column. So 2q plus 3, negative 2, 2. And last row become the last column. So 0 to r minus p, 3. So lastly, you just need to compare. You just need to compare according to its entries. So 4 equals to 4 doesn't give you any values for the constant that we need to find out. So maybe you can choose another entry. So 1 equals to 2q plus 3. So compare. So 1 equals to 2q plus 3. So we get q equals to negative 1. So maybe we can choose another pairs, another comparison. So this one, 2p plus 4 equals to 0. So p, you will get negative 2. And lastly, r. So in order to find out r, so you have to choose this one. So 2 equals to 2r minus p. So 2 equals to 2r minus negative 2. So 2 equals to 2r plus 2. So 2r equals to 0. R you get 0. We're done.